Hello and welcome back to my channel. We're going to be talking about connecting f, f prime, and f double prime. What we're going to be doing is we're going to be taking these things together to end up making the sketch of our original function. Sketching your function is not going to be something you're asked to do on the AP test, but analyzing what's going on with each part is. So in our first piece here, we're going to be doing the finding increasing, decreasing, concave up, concave down, and any points of inflections for our function of f of x is equal to 2x cubed minus 12x squared plus 6x plus 20. So the first thing we're going to do is f prime of x equals 6x squared minus 24x plus 6. This is going to allow me to set this equal to 0 and solve. Before I do that, I'm going to notice that there's 6's in everything here, so I'm going to factor out a 6 from everything. So I have x squared minus 4x plus 1. This is already telling me that I'm going to probably end up using graphing techniques, because if I look here, what multiplies to 1 and adds to negative 4 is nothing that is a whole number. So we're going to be using some decimals here, which means we are not going to be getting what we need from factoring. We could use the quadratic formula. We're going to end up getting the square root of 12 in there somewhere. But for the purposes of what we're doing, we're going to look at the graph. So I have the graph pulled up here. If I pull up our zeros happen at 0.268 and 3.732. This is going to be what our function looks like here. Everything before, so anything before 0.268 is above the graph. Anything after 3.732 is also above the graph, and then everything in between those two x values are below. This is the graph of our first derivative, so this is our derivative graph, which means that anything above the x-axis is going to be positive, which means that it is also increasing. Anything below our graph, or below the x-axis, is negative, which means it is decreasing. So 0.268 and 3.732. So we would do what we would normally do, which is make our table. We looked at the graph, so we kind of already know what's going on. But if I were to do this by hand, I would pick a value or values around what we have here. So I might pick 0, 1, and 4, just to kind of help out here. If I plug in 0, I know that it would give me a positive value for the first derivative, because it would be plus 6. If I plug in 1, 1 squared is 1, so 6 minus 24 plus 6, well, 6 plus 6 is 12, so I already know this is going to be a negative. And then if I plug in 4, 4 squared is 16. 16 times 6 is 96. We're going to take away 24 times 6, and then add 6 to it. And we know that that's going to end up being, it helps if I put in the right number. 24 times 4 is what we were taking away. So we have 6 squared. Oh my gosh, I keep saying 6. When we looked at the graph, we know it's going to be positive, so we are going to have a positive here. If I can actually do the right math for this, we have 16 times 6, because it's 4 squared, which is 96. 4 times 24 also happens to be 96, so those cancel each other out, and then we add 6 to it, which means we are going to have a plus 6. When I look at this, because my derivative is positive, I know that this is going to be increasing, we're going to be decreasing, and we're going to be increasing. So I know I'm going to have some information here. So I'm going from increasing to decreasing. This means it is going to be a maximum right here. I'm going from decreasing to increasing, so this is going to be a minimum. Those would both be relative minimums because we don't know what else is going on and we're not looking at those endpoints. Now that I have my increasing versus decreasing, so I know I'm increasing when x is less than 0.268 and when x is greater than 3.732 because f prime of x is positive. I know that we are decreasing when x is in between that 0.268 and 3.732 because f prime of x is decreasing. Okay, so now we're going to look for concavity, so I'm going to take my function that we have, so f prime, and take the derivative of it to get f double prime. So we have 6x squared, that's going to turn into 12x minus 24. This is much easier to work with. So we have 0 is equal to 12x minus 24. So 24 is equal to 12x. So 2 is equal to x. So we have a possible point of inflection here. We just need to analyze it a little bit more to decide what's going on. So I have my value x that we're going to be looking at here, 2. And then we need to look at f double prime, which will tell us about f of x. So I'm going to pick 0, and I am going to pick 3. So I have 0. If I plug in 0, we're going to get negative 24. So this is going to be negative. If I plug in 3, 12 times 3 is 36. 36 minus 24 should give us 12. So we're going to have a positive over here. So this means I'm concave down, then I'm concave up, which means at 2 we have a point of inflection because it changes concavity. So we are concave down. When x is less than 2. Because f double prime of x is negative. I am concave up when x is greater than or equal to 2 because f double prime is positive. And I know I have a point of inflection. Because that is where we are changing concavities. So I know a little bit of information. I'm increasing before and after the critical points. I am decreasing in between our critical points. I have a point of inflection at 2. I am concave down before, I'm concave up after. So there's a few more things that we want to know in order to kind of help us out. So x and y intercepts. Our original function is 2x cubed minus 12x squared plus 6x plus 20. So if I want to find a y-intercept, I'm going to plug in 0 for x. And we get f of 0 is equal to 20, so our y-intercept is 0, 20. Our x-intercept, on the other hand, we're going to take that function and set it equal to 0. So 0 is equal to 2x cubed minus 12x squared plus 6x plus 20. If we weren't able to use a calculator, or even if we were, one of the first things that I would do is factor out a 2 from everything. So I have 2 times x cubed minus 6x squared plus 3x plus 10. And then the next thing that I would do if I didn't have a calculator is test out different factors using polynomial division. So what I would probably do is, I'm seeing 10 at the end here, so 10 is made up of 2 times 5, 1 times 10, so I might try something in there. We're going to start with 2 times, or x plus 2, and see if that works. So what I'm going to do is I'm going to quickly use polynomial long division and see if I can find this factor. So I'm going to bring down this first term. 2 times negative 2 is negative 4. Add those together to get negative 10. Negative 10 times negative 2 is 20. 20 plus 3 is 23, and I can already see for sure that's not going to work. So what I'm going to do is I'm going to change it. Instead of x plus 2, I'm going to try x minus 2 and see if that works. So I'm just changing it to this. So we have 2 times 2 is 4. And if I add these together, negative 6 plus 4 is going to be negative 2. Negative 2 times 2 is negative 4. This would give us negative 1. Negative 1 times 2 is negative 2, and that didn't work either. So then we might try something else. So the next thing I might try would be 5. So 2 times 5 is 10. 10 minus 6 is 4. 4 times 5 is 20. That gives us 23. 23 times 5, not going to work. So then we might try negative 5. You know, this would work if I would have not wrote the problem down wrong. So let's try negative 5 anyways to see if it'll work. So this will be 1. This will be a minus 5. Actually, plus 5 is going to work. So 1 times 5 is 5. 5 minus 6 is negative 1. Negative 1 times 5 is negative 5. Negative 5 plus 3 is negative 2. Negative 2 times 5 is negative 10. So this is a 0. So we have x squared minus x minus 2. So I know that this would give me 2 times x minus 5, because 5 would make x minus 5 equal 0, which is how we got that number in the house, times x squared minus x minus 2. I can factor x squared minus x minus 2. What multiplies to negative 2 and adds to negative 1 is negative 2 and positive 1. So I get this. If I were to add all of these, or find the zeros for all of these, going to set each one of these equal to 0. X equals 5, x equals 2, x equals -1. So that was the long way of doing it. The better, well, the faster way would be to just have it in our problem. So x cubed minus 6x squared plus, be easier if I just had it next to me, 6x squared, 3x plus 10. And if we look here, -1, 2, and 5 are those x-intercepts. So we get the same thing. Obviously, graphing it is way faster. Okay, so I'm going to stop the video here, and then we'll restart so we can start back at the graphing part of this and kind of bring it all together.